Supposed to find the critical points of the function, decide whether that critical point or points is a minimum, maximum, or inflection point. Well, the first thing you want to do is you want to find critical values by taking the first derivative, setting it equal to 0. The first derivative is going to be 2t plus 2. Set that equal to 0. Lots of ways to solve this. I'm going to factor. Wouldn't have to factor. You could just subtract 2 from both sides and then divide by 2. If you choose to factor, you then set each factor equal to 0. And you end up with t is negative 1 and 0 equals 2. 0 does not equal 2. It's a false statement. So from the first derivative, we have a critical value of t, which is negative 1. Step 2, see if you can find more critical values by taking the second derivative. That's the derivative of the derivative. Derivative of 2t is 2. Derivative of 2 is 0. Set it equal to 0. You get 0 equals 2. No, it doesn't. So we only have one critical value. That means we only have one critical point. Step 3 is to figure out what the critical points are. To do so, take the number, the critical value, plug it into the original function. If you plug a negative 1 into the original function, you get a negative 16. So from this, we have one critical point. It's negative 1, negative 16. Now we need to decide, is this critical point a minimum, a maximum, or an inflection point? So this is step 4. I'm going to take the x value from my critical point, which is known as the critical value. I'm going to pick other x values close to that, one to the left and one to the right, such as f of negative 2, g of negative 2, and g of 0. On a number line, negative 2 is to the left of negative 1 and 0 is to the right. If I put those into my function, negative 2 gives me a negative 15. A 0 also gives me a negative 15. So once again, I'm putting these test points in, comparing them to this green test point. I pick one to the left and one to the right. And then I compare these y values to the y value of that critical point. Negative 15 is above negative 16. Negative 15 is also above negative 16. If all the neighboring points to the left and to the right are above it, that makes this a minimum at negative 1 and negative 16. So we have a minimum, negative 1, negative 16. We have no maximum, we have no inflection point. All right, number 2. First we find critical values from the first derivative. Set that equal to 0. This time, instead of factoring this, I'm just going to solve for x using conventional means because factoring is not necessary. With a critical value of 2/3. Second step, find more critical values by taking the second derivative. The derivative of 6x minus 4 is 6. Set it equal to 0. You'll see that 0 does not equal 6. Third step, take all your critical values, and this one only has one, plug it into the original function. Original function is f of x, so this would be f of 2/3. put that into the original function into my calculator, it's going to come out to be negative 1/3. Or perhaps negative 0.3 repeating. So my critical point is 2/3, negative 1/3. Hopefully you recognize that 2/3 as a decimal is 0.6 repeating. When given the opportunity, I prefer to leave the exact answers. Step 4. Decide, is this a minimum, a maximum, or an inflection point? So to decide that, take test points to the left and to the right of our critical value. Our critical value here is 2/3. Pick a number to the left of 2/3, pick a number to the right of 2/3 on a number line. To the left, I could pick 0. If I put that into my original function, it's going to give me a 1. To the right, I could put a 1 in. If I put a 1 in, it's going to give me 3 minus 4, which is negative 1, plus 1 is going to give me 0. Now I'm comparing those y values with the y value in my critical point. A 1 is above negative 1/3. A 0 is also above negative 1/3. So if all the neighboring points are above, that makes this a minimum at 2/3, negative 1/3. This graph has no maximums and it has no inflection points. Incidentally, it should be mentioned that you should know going into this problem with doing no work what kind of critical points you're going to have. If you look at this function, you should know it's a parabola, and then you should also know, since the lead coefficient is positive, this parabola is going to open up. If the lead coefficient is negative, it's going to open down. If it opens up, there's a minimum. If it opens down, there's a maximum. Same directions here for number 3. Step 1, find the derivative. Set it equal to 0. I'm going to factor the GCF out of this. I'm going to set each factor equal to 0. Solve each of these little equations. We did this to find critical values. So I'm going to label it. We got critical values of x is 0 and 1/3. Second step, find more critical values by taking the second derivative. So the derivative of the derivative would be 12x minus 2. Set that equal to 0. I'm going to solve this by factoring. You wouldn't have to do that. Set each factor equal to 0. 0 equals 2. No, it doesn't. 6 minus 1 equals 0. So here we got critical value of 1/6. We have 3 critical values. That means we're going to have 3 critical points. Step 3, find the critical points. To do so, take your critical values and plug them into the original function. I suggest when you write these down, you write them in ascending order from smallest to greatest. 0 is the smallest. 1/6 is a little bit bigger. 1/3 is a little bit bigger than that. F of 0 is 1. F of 1/6 is 0.98. F of 1/3 is 0.96. I made a mistake here and said this is what these numbers are. It's not true. It's what they are approximately. These are rounded numbers. Quite frankly, I hate rounded numbers. but I'm going to round them just to make this a little bit easier on you. Although know that it pains me to write that. So we got 3 critical points. We have 0, 1, 1/6, 0.98, and 1/3, 0.96. We need to decide each of these critical points if it's a minimum, maximum, or inflection point. I can tell you right now what each of these are. This one here is a maximum. This one here is an inflection point. This one here is a minimum. I'm 100% certain with doing no work. Regardless, we're going to do the work, and then I'll show you how I know that just by looking at it, and you probably know it as well. Hopefully. Hopefully. So here's the work that you can show for this. We're looking at these 3 critical values. 0, 1/6, which is approximately 0.17, and 1/3, which is approximately 0.33. When you pick test points, you do something to the left of 0, between 0 and 0.17, between 0.17 and 0.33, and to the right of 0.33. For example, test points could be -1, 0.1, 0.2, and 1. So let's first focus on this gray. I need to figure out what f of -1 is and what f of 0.1 is. I'm going to be comparing this to that first critical point, the one that's in gray, 0, 1. Using a calculator, if I put -1 in here, I get -2. If I put 0.1 in, I get 0.99, approximately. I'm comparing these to the y value in this first critical point. So -2 is below 1. 0.99 is also below 1. So as I said earlier, I knew this was a maximum at 0, 1. Then I'm going to check out these yellow numbers. A yellow critical point. So pick something to the left, such as 0.1, which is 0.99. To the right, f of 0.2. Using a calculator, it's 0.98 approximately. Should be using a wave equal sign. Comparing those to this y value of 0.98. Now here we have a problem. It appears as though 0.98 is the same as 0.98. It can't be the same, so I need to backtrack a little bit. I'm going to take this out to another decimal place. This is actually 0.976. That's what it is exactly. This 0.98 up here is not that exactly. Let me recheck that with the calculator. 1 divided by 6. This is actually 0.98148. There's more decimals than that. But you need to carry it out to at least enough that you can compare to see that these are different. So I'm comparing 0.99 to 0.98. This is above it. I'm comparing 0.976 to 0.98. 0.976 is below 0.98. Some of the points are below and some of them are above. That makes this an inflection point at 1/6.98. Finally, I'm going to compare the numbers, test points to the left and right of this critical point. So to the left, we'll say 0.2. To the right, we'll say 1. Comparing these y values to this green y value, 0.976 is below, pardon me, it's above 0.96. It's higher. Two is also above 0.96. If the neighboring points on both sides are above, it means this point is pretty low. If everything is above it, it's a low rider. So 1/3 0.96 is a minimum. So let's transfer these answers down here. Be careful to put them in the right spots. Minimum 1/3 0.96, maximum 0.1, inflection point 1/6.98. Now I told you at the beginning I knew these were the right answers before we even did the problem. You can do the same. It's pretty simple. This resembles the parent graph y equals x cubed, which looks like this. As long as the lead coefficient here is positive, this is how this graph is going to look. When you start throwing in these other variables, same variable with different exponents, I should say, it's as if you were to grab a hold of here and grab a hold of here to this graph and pull it apart. If you pull it apart, it's going to look like this. As long as the lead coefficient is positive and it's x cubed, and you have 3 critical points, your first one is always a maximum. Your second one is always an inflection point, and your third one is always a minimum. Now if that was a negative in front of this, if it was a negative x cubed and a bunch of garbage after it, then it would look like this. It would have a minimum first, then an inflection point, and then a maximum. Remember, this negative reflects the graph over the x-axis. So that's how I knew that's the way it was. Number 4. Well, technically you could do no work for this and I would give you full credit. This resembles the parent graph y equals x to the 5th, which is a real skinny version of y equals x cubed. This is in the same form of that, but it's got this minus 28, so it takes it and translates it down 28. So instead of being up here like this, it's down here like this. That inflection point is 0, negative 28. First thing you want to look at when you look at these equations, is it in the correct form? Correct form being like so. Y equals some number times the function, and then inside that function maybe you're adding or subtracting something, and this is to some exponent. Let's not use k. Let's use c. So this fits this form, and for this problem a is 1. Our function is w to the 5th. So we have a w minus 0 to the 5th plus 0. This all reduces to just, pardon me, this shouldn't be plus 0, it's minus 28. Same form. If it's in the correct form, then you can just find the answer just by looking at it. But you didn't know that, so let me show you the work. Step 1, first derivative to find critical values. This first derivative is 5w to the fourth. Set it equal to 0. Do the fourth root to both sides, and you get plus or minus 0, which is ridiculous. It's just 0. Step 2, find more critical values by taking the second derivative. This should be w or v prime, pardon me. Take the second derivative. Guess what? You also get 0 for this. So it appears as though there's two critical values, but there's not. It's just repeated. If you plug this into the original function, you get negative 28. If you pick test points to the left and to the right, and to the right of 0, you get negative 29 and negative 27. This is below. This is above. You get some above and some below. It's an inflection point. Yay! Number 5, find the x and y intercepts of the graph. To do this, you need to factor. And if you want credit for it, you need to factor correctly. There's a systematic way to factor anything that can be factored. Simply writing down the factored version without any explanation is unacceptable. It's a coward's way out. I am not a coward, and nor should you be. This is a trinomial. There's 3 terms. First step in any factoring is to factor out the GCF. If the GCF is 1, then you skip that step. This GCF is 1. Second step, see if this is a perfect square trinomial. To see if it is, first is the first term a perfect square. You betcha. Its square root is 2x. Is the last term a perfect square? No, it is not. Therefore, this is not a perfect square trinomial. Third thing you check for, and this is something you only have to check for if the lead coefficient is not a 1, although technically you should do it when it is a 1 as well. This is not a 1, so let's just skip that discussion. So we got 3 terms, no GCF, not a perfect square trinomial. You are then to split the middle term and factor by grouping. This is the middle term. It needs split so that there's 2 terms. Why does it need split so there's 2 terms? So you can factor by grouping. Grouping only works if you have an even number of terms. So 16x is going to get split into 2 things. Something x plus something x. It needs split so that it means the same thing as 16, but it looks different. So how do you decide how it's split? Well, it's really simple. You need 2 numbers that multiply to get a times c. Those same 2 numbers add to get b. A is 4, b is 16, c is 15. 4 times 15 is 60. b is 16. 2 numbers that multiply to get 60 and add to get 16. If you don't know the answer, and I'm sure that you know the answer, but if you don't know the answer, simply list all the factors of 60. One combination is going to have to add up to 16. If it doesn't, if you list all factors of 60 and no pair adds up to 16, then you can't factor this. So just for the sake of how would you do this in a systematic way, let me show you. Let's assume that you don't know the answer to this. Start with the number 1. Does 1 go into 60? Sure does. 60 times. What is 1 plus 60? Well, that's 61. Doesn't work. Does 2 go into 60? Sure does. 30 times. 2 plus 30 is 32. Doesn't work. Does 3 go into 60? 60 is a terrible number. So many things go into it. Once again, I know that you know the answer, but I'm just showing you how you would do this systematically, so that if you don't know the answer, you can just exhaust all the possibilities. And once you've exhausted all the possibilities, if nothing works, then you can rest easy knowing that it doesn't factor. Should be 4 plus 15, not times. Pardon me. Getting warmer, getting closer. 5 goes into it 12 times. Six goes into it 10 times. Now this one worked. Let me just show you. Let's assume it didn't. 7 doesn't go into it. 8 doesn't go into it. Oh yeah, 8 does go into. No, 8 doesn't go into it. 9 doesn't go into it. 10 does. But look, 10 goes into it 6 times. We're repeating the same things that we just did. So you don't have to do that. Then there's the negative versions. It could be -1 and -60, -2 and -30. But if you do that, you're adding up to get negative numbers, so those aren't going to work. If you exhaust this list and nothing works, then you can just say, doesn't factor. Once you get these numbers, 6 and 10, put one of these on one of the blanks and one of them on the other. Doesn't matter which is which. That is called splitting the middle term. Once you've split the middle term, well, let me back up a second. Forgot what I'm doing here. I just started factoring. Let's define the x-intercepts. To find x-intercepts, you set this equal to 0, and you factor it. So here's how you split the middle term. Pardon me, we did that. Here's how you factor by grouping. You group terms together that have common factors. We have not changed the value of this problem, we've just changed the way it looks. We changed the 16x to a 6x and a 10. We changed it from 4 terms to 2 groups of terms being added together. The values haven't changed. So this is by grouping. Once you group terms together, find the GCF of each group. Now we have 2 terms left. This is one term. This is the second term. What is the GCF of those 2 terms? What do they both have in common? Well, they both have a 2x plus 3. I think I should color code this for your viewing pleasure. So we factored that green 2x plus 3 to the front. What's remaining, what's left, is a 2x plus a 5. Once it's factored, take each factor, 2x plus 3, and 2x plus 5, set them equal to 0. Solve each of those little equations. As usual, I'm running out of space. So we get x equals -3/2. Here we get x equals -5/2. So x-intercepts -5 halves, -3 halves. should do a better job of labeling my work. X-intercept, plural, intercepts. Y-intercept. 90% of the time the y-intercept is just a joke. Simply put 0 in for your x's, because any place on the y-axis the x value is 0. Get a y-intercept of 15. Alright, number 6 here, I want to find the x-intercepts. Replace g of x with 0. First step in factoring is factor the GCF. GCF is x. This factors more. It's a trinomial. It is not a perfect square trinomial because 35 is not a perfect square. You do not have to split the middle term because the lead coefficient is not 1. If you did split the middle term and factor by grouping, you'd get the same result that you're going to get right here. Two numbers that multiply to get a times c. A is 1, c is 35. Same two numbers add to get negative 12. That would be a minus 5 and a minus 7. If you split the middle term into a minus 5x and a minus 7x, grouped it, you'd get the same result that you see here. Then you take each factor, set it equal to 0.
Okay, I get it. I really don't get it, but...
And then you solve each of these little equations. So we get x-intercepts of 0, 5, and 7.
Are you done with that box?
So how do you find the y-intercept? As always, replace the x value with 0. And that makes this easy peasy in the month of Parcheesi. Just be careful that you don't sneezy. So we have a y-intercept of 0. Number 7, 3 terms, trinomial. Is it a perfect square trinomial? First term is a perfect square. The last term is a perfect square. Maybe it is. To see if it is then, take the square root of the first term, x squared, square root of the last term, 6, multiply those and then double it. Does that give you the same as this middle term? And you can ignore the sign. It doesn't. This gives you 12x squared. That gives you 13 negative style, not the same. So we'll just take this and throw it in the garbage, but you should check that. You do not have to split the middle term because the lead coefficient is 1. So if we can just find two numbers that multiply to get 36 and add to get negative 13. Such as negative 9 and negative 4. X squared minus 9 is the difference of two squares. That's one of your factoring rules. X squared is a perfect square, and 9 is a perfect square, and it's a difference. This factors into an x less 3 and x more 3. X squared minus 4 factors into an x minus 2 and an x plus 2. Take each factor, set them equal to 0, these mini equations. Solve each of those and you get x is 3, x is negative 3, x is 2, and x is negative 2. So x-intercepts, we could simply say plus or minus 2, plus or minus 3. To find the y-intercept, simply replace the x values with 0. So you get f of 0 equals 36. Y-intercept, 36. Number 8 says graph the function. Be sure to label all critical points and all intercepts. To graph this, we need to know what the critical points are. So to find those, you find the first and second derivative, set them equal to 0 and solve them. Plug those critical values into the original function to get critical points, then pick test points, yada yada yada. 2 hours later, you're finished. Step 1, find critical values. To do that, you find the derivative. Set it equal to 0. Factor when necessary. It is necessary here. Set each factor equal to 0. When you square root x squared minus 1, x squared equals 1, I should say, you get plus or minus 1. So our critical values from the first derivative, -1, 0, and 1. Step 2, find more critical values from the second derivative. Second derivative would be 12x squared minus 4. Set it equal to 0. Set each factor equal to 0. 0 equals 4. No, it doesn't. So we end up here with x is plus or minus square root of 1/3. Let me tell you what that is approximately. As much as I hate approximations. That's about 0.577. So from the second derivative, we found 2 more critical values. Third step, find critical points. So we take these 5 critical values and we figure out what the y values are to make critical points. Put these in from lowest to highest, from smallest to greatest. So we got f of -1, followed by f of -0.577, followed by f of 0, followed by f of 0.577, followed by f of 1, from smallest to greatest. Just so you know, I know right now what each of these are going to be. Minimum, inflection, maximum, inflection, minimum. You can tell just by looking at the original function. Hopefully in time you'll be able to do that too if you can't already. Putting these into my calculator right now. Monkey with me. I mean, bear with me. Sorry about that. I get those sayings mixed up. If you put -1 in, you get -9. If you put the square root of -1/3 in, you get approximately a -8.556. Put 0 in, you get -8 exactly. If you put positive square roots of 1/3 in, you get -8.556. If you put 1 in, you get -9. So we got all these critical points. Now, unfortunately, we got to figure out what each of these are. So there's a lot of things to put into our calculator. I need to pick different test points. Let's put this on a number line here. So to the left of -1, such as -2. Between -1 and -0.577, what's what negative square root of 1/3 is? Perhaps -0.8. Between that and 0, perhaps -0.1. Between 0 and this, we're going to say +0.1. Between 0.577 and 1, let's go 0.8 again, and to the right of this, 2. Gotta take all those ungodly numbers, put them into our calculator. Oh geez, sorry about that. User error. I think I left off my 2. I don't know if you can see it. So let's do this. So we're going to put in f of -2 and f of -0.8. Do some comparisons. We're going to put in f of -0.8 and f of -0.1. Do some comparisons. I'll tell you what, there is no room to do all this. Let me fix it. So I made this smaller so I can fit this in here better. And then we're going to have to go -0.1 and +0.1. And then 0.1 to 0.8. 0.8 to 2. 1, 2, 3, 4, 5, because I have 1, 2, 3, 4, 5. Now when you get this many things, it's just super confusing. So let me do a couple things to separate these, to physically separate them, which for me it helps tremendously. If it doesn't help you, don't do it. This is being compared with this. This one is being compared to this point. This one goes with these. This one goes with this one. And this one, 1, -9, goes with this one. I put these numbers into my calculator. I put those numbers in my calculator here. I get a 0 for this, -0.87, -8.87 I should say, -8.87, -8.02, -8.02, -8.02, -8.02. Notice the symmetry here. That means this graph is symmetric with respect to the y-axis. And then 0.8 and -8.87. And 2 is 0. So I'm comparing these to negative 9. This is above. This is above. If they're above, that makes this a minimum. -1 and -9. This is comparing this to negative 8.556. This is below. This is above. It makes this an inflection point. Your biggest enemy on these problems is your own handwriting. If you don't write legible, you're going to write something wrong, and then you write it wrong again, and it's just a mess. Negative 8.02 is just a little bit below negative 8. This is just a little bit below negative 8. That makes this a maximum at 0, negative 8. Negative 8.02, comparing that to negative 8.556. This is above. This is below. Makes this an inflection point. And then we're comparing these last two numbers with negative 9. This is above. This is above, which makes this a minimum. So we got all the critical points straightened out. Now we still got to find x and y intercepts. Oh joy. So step 4. So let's see, we got x to the 4th minus 2x squared minus 8. X-intercepts. Set this equal to 0. See if this factors. I take each factor. Well, I factor it first. Two things that multiply to get negative 8 and add to get negative 2. How about negative 4 and positive 2? X squared minus 4 factors some more. It's the difference of two squares. X squared plus 2 does not factor anymore. It's a sum, and it's not a sum of two cubes, therefore it doesn't factor. Set each factor equal to 0. And I get x is 2. X is negative 2. And here I get an imaginary answer. The square root of a negative number is imaginary, which means our only x-intercepts are positive and negative 2. This is step 5, by the way. To find y-intercepts, y-intercept, there can only be one for a function. Replace the x value with 0. We get a y-intercept of negative 8. So we have 1, 2, 3, 4, 5, 6, 7, 8 points to graph. Let's see if we can do this. Alright, so let's see. We have a minimum at negative 1, negative 9. So let's say that's here. We have a maximum, or another minimum, at 1, negative 9. We have a maximum at 0, -8. Let's say that's here. And we have inflection points between them. So about here is an inflection point, about here is an inflection point. I'm going to label those as well. This inflection point was positive square root of 1/3, -8.556. This one was a negative square root of 1/3, -8.556. I had x-intercepts of 2 and -2. Hopefully you can visualize what this looks like. Here we have a maximum. So that means we have this curve that's concave down. And here we have a minimum. This inflection point changes the concavity. So it looks like this. Keep in mind this -2 here is just an intercept. It's not a critical point. So the graph continues from there. Just keeps going up forever. Here is a minimum. So it comes down and comes back up. Continues through that x-intercept. So that's what the graph looks like. All right, number 9. Find critical points, intercepts. Find critical points, you first find critical values. To do that, you take the first derivative, set it equal to 0. Solve that equation. Square root both sides, we get plus or minus the square root of 7/3. Incidentally, that is approximately 1.53. You need to know what that is approximately, so when you pick test points, you pick them in the right direction. Number 2, we can find more critical values by taking the second derivative, setting it equal to 0. You should know right now, with no work, what these critical points are. You should know which one's a minimum, which one's a maximum, which one's an inflection point. Step 3, determine the y values of your critical points. So we got 3 of them. When you do this, do it in ascending order from smallest to biggest. 0's in the middle. Square root of 7/3 is the biggest. Negative square root of 7/3 is the smallest. I think I can do better than that. Put this in my calculator. If I put negative square roots of 7/3 in, I get approximately 1.13. If I put 0 in, I get -6. If I put the square root of 7/3 in, I get -13.13. These are approximations. So my critical points Now I have to determine which each of these are. And I'll tell you right now, this is a maximum, this is an inflection point, this is a minimum. The same logic that I showed you in an earlier problem. I forget which one, maybe number 7. But let's show you the work. I need to pick a test point to the left of negative square roots of 7/3, such as negative 2. I can pick a test point between negative square roots of 7/3 and 0, such as negative 1. And then between these numbers and to the right of, well, between these numbers, I should say. And then between these numbers and to the right. Once again, this is coming from this point. This is from this point. This is from those. I put this in my calculator. Let me do that real quick. I get 0, 0, 0, negative 12, negative 12, negative 12. Comparing these zeros to 1.13. This is below. This is below. Comparing these numbers to negative 6. This is above. This is below. Comparing these numbers to negative 13.13. This is above, and this is above. It does not take a rocket scientist to figure out these answers without doing any of this work. So that makes this a maximum, this an inflection, and this a minimum. So last thing we have to do here is we need to figure out what the x and y intercepts are. Let's do the y-intercept first. So to find the y-intercept, simply put 0 in for your w's. When you substitute, you're supposed to use parentheses. So we get negative 6. Which we already had that, so it's a little redundant. X-intercept. This is also step 5. We set this equal to 0. I think I made a mistake earlier, now that I'm writing this. Yeah, I apologize. Up here, these were W's, and then magically they changed to X's. I'm not a real big fan of the magic. So let me fix that. So sorry. Hopefully you caught it when I was doing it. Hopefully you were screaming at your monitor. No! Please, stop! You're killing me! In your best Mickey Mouse voice. That was my best Mickey Mouse voice. Pretty bad one, wasn't it? Pretty bad one. All right. So factor this. This doesn't factor. If I don't know if I can even give you a rule here, but basically, if this is a cubed, which this is, and there's no GCF, and there's 3 terms, then this either needs to be, well, it's just not going to factor. I don't know what else to say. If the GCF is a 1, and it's 3 terms and it's cubed, it's not going to factor. Maybe there's an exception to that I don't know about, but I don't think so. So we say doesn't factor. So what do you do when it doesn't factor? Use your calculator, because we don't know any other way. Well, I know other ways, but at this point you don't. If I use my calculator, here's what I'm going to do. So I asked the calculator from my W-intercepts, and they're here, -2, -1, and 3. So let's graph all this on here. So I got these intercepts. Let's say this is -2, and this is -1, and this is 3, we'll say. And then my critical points, what were I had a maximum at negative square root 7/3 1.13. Let's say that's here. Had an inflection point at -6. We'll say this is -6. And a minimum at 7/3 square root of 7/3, -13.13. We'll say that's this. So your graph, we have this maximum, graph comes up, hits the maximum, comes back down, continues to come back down until it hits this inflection point, which I'm going to now move it down here. We have this minimum, goes down and comes back up, goes up forever. So that is the graph. All right, number 12, supposed to find the derivative. I skipped 10 and 11 because those are calculator problems. I'm pretty sure you're okay with that. So number 12 looks a little strange. How are you supposed to find this derivative when you don't have exponents? Well, you can change this. The square root of x is really saying 2 times x to the 1/2. The cubed root of x squared is really saying x to the 2/3. And the fourth root of x is really saying x to the 1/4. So when you find the derivative, 1/2 times the coefficient of 2 gives you 1. Subtract 1 from the exponent. Plus 2/3 times 3 is 2. Subtract 1 from the exponent is -1/3. 1/4 times 4 is -1. But you don't have to write the -1. You can just write subtract x. Subtract 1 from the exponent, and you get -3/4. Good enough, right there. All right, number 13, a rectangular exhibit. Let's start out with a rectangular exhibit. Is fenced off for the fall season. The area of the region is 125 square feet. Area, 125,000 square feet. type of fencing costs $20 per foot to be used along the back and the front. Let's call this the front and the back length L. So L is length in front and back. And it's $20 for that. So that means that the cost of the front and the back is $20 times the length of L. A less expensive fence costing $10 per foot was used along the other sides. So we'll say W is the width for, we'll call it with our picture orientation, the left and right. So this is $10 per foot. There's W feet there. This is $10 per foot. There's W feet there. What were the dimensions of the region that minimize the cost? This tells us two things. One, we need a cost function. Two, we need to figure out what the minimum is of that function. So let's say that C is the cost function. So let's make a cost function. The cost is going to be equal to the money that it takes to fence the front plus the money that it takes to fence the back plus the money it takes to fence the left side plus the money it takes to fence the right side. We've already figured out that the front is going to cost $20 per foot. The back is $20 per foot. The left and right sides are each $10 per foot. The left and the right sides are the same, that's why they're both W. The front and the back are both the same, that's why they're both L. If you simplify this, you get 40 times the length plus 20 times the width. We are then supposed to minimize this cost. We can't minimize it because there's two variables. Let me write in steps what we've done first. This is what we're doing second. Now we have to go on a little hacienda. We're stuck here on step 2. We can't minimize it because there's two variables. Hopefully they've told us enough information in the problem that we can get this to be in one variable, and they have. The area of a rectangle is length times width. The area of this rectangle is 125,000 square feet. We can get L or W by itself. This is called solving by substitution. It's a system of equations. So I was on this step here, I got stuck, and I went over here, and now I'm unstuck and I'm coming back. I'm going to replace in this problem all of my W's with L's. So I got 40 L plus 20. Instead of a W, I'm going to write 125,000 divided by L. At this point, I realize that I've taken up way too much space. I'm going to have to probably make this smaller at some point. Simplify this before we try to find the derivative. A couple of things I know. First of all, 20 times 125,000 is 2.5 million. Divided by L. Instead of dividing by L, I'm going to write times L to the negative 1. So at this point, I have a cost function in one variable, which is great. Once I have that, then I need to find the derivative and figure out what the minimum is. So derivative. Derivative of 40L is 40. 2.5 million times L to the negative 1. If I take the negative 1 out to the front, that's a negative 25 million, pardon me, 2,500,000. Subtract 1 from the exponent, 1 minus 1 is a negative 2. Set this equal to 0. I'm going to get rid of my dollar signs now just because they are annoying me. Now you have to solve the equation. I'm going to multiply each term by w squared. Pardon me, L squared. What I'm showing you here in red, you would not have to show this, but I'm doing it just to help you understand. L squared times 0 is 0. L squared times 40 is 40L squared. Here, when you multiply the same base, L's, add the exponents. Negative 2 plus 2 is 0. L to the 0 is 1. So this is minus 2,500,000. Add 2,500,000 to both sides. Divide both sides by 40. I am super duper out of room. Fortunately, I can do crazy things like this. If I divide both sides by 40, using a calculator, I get 62500, 62,500. Square root both sides, I get plus or minus 250. I have a decision to make. Is the front and the back negative 250 feet, or is it positive 250 feet? Negative 250 is nonsensical. It's ridiculous. This is not really a word, but who cares? So, L is 250 feet. Supposed to find the dimensions of this. So this is the front and the back. Well, what about the sides? Take this and put it up here into this equation that I already have solved for W. That gives me 500. Now, how do we know this is a minimum? You can check. You can check that it's a minimum by taking test points to the right and the left of 250, putting them in to this function to see if the y values are yada yada yada. For our purposes, let's just assume that it is whatever it says it's supposed to be, just to save us from the insanity of checking. Trust me, it will minimize the cost. Sentence answer. Let me make sure I got this problem down pat before I start giving it a sentence. What were the dimensions of the region that minimized the cost of the fence? Can't say length and width because the problem doesn't use length and width. So we could say the front and back are 250 feet. And the other two sides are 500 feet each. Lovely. 14. Mufasa is a cotton farmer. If he harvests his crop now, the yield will average 120 pounds of cotton per acre and will sell for 48 cents per pound. However, he knows that if he waits, his yield will increase by 10 pounds per week, but the price will decrease by 3 cents per pound. Let's say that X is the number of weeks Mufasa, I'm sure that's not how you spell Mufasa, waits. So currently, if he were to do this today, if Mufasa were to say, I'm selling my crop now, his revenue Revenue is how much money you bring in. You would take the dollars per pound and multiply it by the number of pounds. And in turn, you'd multiply that by how many acres. But it doesn't tell us how many acres he has. So this revenue would be per acre. So currently, once again, this is not how you do the problem. I'm just trying to explain the process here. He currently could sell it for 48 cents a pound. And he's got 120 pounds of cotton per acre. So if you multiply that, he would make $57.60 per acre. This is if he were to do it today. But when you look through this problem, it says if he waits, each acre is going to produce 10 more pounds per week. But every week he waits, he could sell it for 3 cents less per pound. So let's figure this out. His revenue in X weeks is going to equal, I should say what R stands for. Revenue is R. We're going to take the dollars per pound and multiply it by the number of pounds. Dollars per pound. It's currently 48 cents. It's going to decrease by 3 cents every week. So that's minus 0.03 times X. How many pounds? He currently has 120 pounds. That's going to increase by 10 pounds per week. So it increases by 10x. This is our revenue function. If we multiply this out to simplify it, here's what we'll get. Multiplying 0.48 times 120, we get 57.60. It's multiplying these two together. If we multiply 0.48 times 10x, we get 4.8x. If we multiply negative 0.03x times 10x, we get negative 0.3x squared. I'm trying to write my terms in descending order, that's why I'm writing them in crazy places here, seemingly crazy places. And what's left? I'm going to need to multiply 120 times negative 0.03 gives me negative 3.6x. If I combine like terms, I get negative 0.3x squared plus 1.2x plus 57.6. Hopefully you can tell here this is a parabola. It opens down because there's a negative coefficient in front of x squared, it's a negative a, and therefore it's going to be a maximum. This says maximize the profit, so we got to find the derivative. It'll be negative 0.6x plus 1.2. Set it equal to 0. Get x by itself. Divide both sides by 0.6. You get 2. Critical value of 2. He should wait 2 weeks. How many weeks should he wait to maximize his profit? So word problem, sentence answer. Mufasa should wait 2 weeks to maximize profit. Question B, what is his maximum profit? Well, I can't say for sure. This question would have been better if it said, what is his maximum revenue? Because we don't know what his costs are to run this cotton farm. But the money that he's bringing in, we can use this revenue function. So we have a revenue function. I'm just going to copy this down. Negative 0.3x squared plus 1.2x plus 5760. So simply put a 2 into this function. And simplify this. 2 squared is 4. 2 times 1.2 is 2.4. 4 times 3 is 12. This is a decimal here, so it's a 1.2. A negative times a positive is a negative. Negative 1.2 plus 2.4 is 1.2. 57.6 plus 1.2 is 58.8. So Mufasa's maximum revenue per acre is $58.80. Mufasa has a maximum revenue of $58.80 per acre.